Hello, let's solve this question. It's given 7 identical circular planar discs, each of mass m and radius r, are welded symmetrically as shown. The moment of inertia of the arrangement about the axis normal to the plane and passing through the point is. So let's start. It was asked to find the moment of inertia about an axis which is perpendicular to the plane which this structure exists, right? Which is at a distance r 3r from this center. So to find this, let's first figure out the moment of inertia for a planar disk. So let's consider a planar disk which is having a mass m and radius r. Right. So let's figure out the moment of inertia for this case. From the formula I equal to r square dm. For this case, figure out the elemental mass. Because this is a circular symmetry, you can figure out this as an elemental mass, which is this mass. Let's assume that strip of mass dm. This is of dm mass, and this is r and dr. Right? Then this is elemental strip is mass. Total mass is m by the area is pi r square into the elemental area is 2 pi r into dr. Right? This pi will go off. Then we are left with 2m by r square into r dr. Fine. Then I value is integral. Integration limits are 0 to capital R. 2m by r square is constant. Keep it out of the integral. Then we are left with r square into r dr, which is 2m by r square into this will be r cube. Then this will become r power 4 by 4. This will give r square and 2, which is m r square by 2 for a disk of mass m and radius r. So now let's figure out the moment of inertia of this structure about the center of mass, which is O. Then we'll go for finding out the moment of inertia about the point P using the parallelaxis theorem. Fine. As you can see, for this first case, which is this first one circle, it's having a center there, which is coinciding with origin. So it is having I equal to mr square by 2. Right. Now, what about this case? If I consider some second circle here, this circle, for this case, the moment of inertia of this circle about this its center is mr square by 2. But we are figuring it out about the center, the structure center, which we can figure out by using, let us assume this is circle 2. Right? For circle 2, using the parallelaxis theorem states that the moment of inertia about an axis parallel to the centered axis is I equal to I naught plus mr square, right? Let's figure it out here. I is I naught plus mr square, right? This is about the centroid, the moment of inertia, and if we need to figure out some axis parallel to that axis, centered axis, we need to use the parallelaxis theorem, right? For second circle, it is I naught value is about its center of mass. The second circle center of mass, it is m r square by 2, and it is having a mass m which is at a distance, this distance, which is 2r, right? This is the case. Then what about the other circles, which is this is 3, this is 4, this is 5, this is 6 and 7. How many cases are there? 1 2 3 4 5 6. There are 6 circles, right? So totally I naught, which is about this center, the moment of inertia of all the circles is, for center one it is mr square by 2, and for the other 6 circles which are surrounding it, 6 circles, right? Because of symmetry, then this will be m r square by 2 plus m into 2r whole square. Let's simplify this. This is m r square by 2 plus this will be 3 m r square plus 6 into 2 square is 4 m r square. So this will be m r square by 2 plus 3 m r square plus 24 m r square, which is equal to 55 by 2 m r square. Fine. This is I naught. I naught is 55 by 2 m r square. This moment of inertia is about this centroid, which is about O for the complete structure. So, right, we need to figure out the moment of inertia about this point P, which is at a distance of r plus r plus r, which is 3r. From moment of inertia, then the I about this point, the moment of inertia about this point is equal to I naught plus what is the mass? Now it's complete structure, right? How many circles are there? There are 7 circles, right? I naught plus 7 times the mass into r is 3r square. So this will be 55 by 2 mr square plus 3 square is 9, 9 7 63, 63 mr square, which can be written as, simplifying this, IP will get 181 by 2 mr square. So this is the moment of inertia about the point P.